Hey guys, welcome back to my channel. So you all had to endure my disappointment in Artemis 2 not launching this year, which is still, I know, totally reasonable delay. I'm just still slightly sad about it. But there does seem to be a 2024 launch on the horizon that actually looks really interesting and is due to launch in October of 2024. And this launch will actually be investigating one of the most interesting planets in our solar system, Jupiter's ice-encased moon, Europa. Because beneath that frozen surface lies a salty ocean that has more water than all of Earth's oceans combined. Correct, combined. And where there's water, there can be life. So let's take a look at this expedition to Europa and discuss the usual suspects of the why, the when, and the how. Because I think I covered the what and the where already, right? Set to launch from Kennedy Space Center in Florida in October 2024, NASA's Europa Clipper will head to Jupiter's ice-encased moon Europa, where a salty ocean beneath the frozen surface may hold conditions suitable for life. It's a good-sized spacecraft. With all solar arrays deployed, it's about 100 feet or 30 meters across and weighs about 13,000 pounds, though about half of that is propellant. It's a solar-powered spacecraft, so it will fly by Mars and then back to Earth using the gravity of each planet to increase its momentum. These so-called gravity assists will provide Europa Clipper with the velocity needed to reach Jupiter by 2030. So yeah, it's gonna take a minute. And when it does, it will orbit Jupiter for another 4 years, performing 49 flybys of Europa and using its suite of 9 science instruments to investigate the moon's potential as a habitable environment. These instruments were recently added to the massive spacecraft at JPL here in Southern California. These include a magnetometer, mass spectrometer, surface dust analyzer, and spectrograph, amongst others. According to the mission project scientist, Robert Pappalardo, the instruments work together hand in hand to answer our most pressing questions about Europa. We will learn what makes Europa tick, from its core and rocky interior, to its ocean and ice shell, to its very thin atmosphere and the surrounding space environment. The hallmark of Europa Clipper's investigation is how all the instruments will work in sync while collecting data. During each flyby, the full array of instruments will take measurements and images that will be layered together to paint a full picture of the moon. The science is better if we obtain the observations at the same time, Pappalardo went on to say. What we're striving for is integration, so that at any point we are using all the instruments to study Europa at once, and there is no need to have to trade off among them. And as I said before, the goal is to learn more about the moon's interior, so each instrument has a specific purpose towards that goal. The magnetometer, for example, will measure the magnetic field around the moon. And this is key to understanding the ocean because the field is created or induced by the electrical conductivity of the ocean's saltwater as Europa moves through Jupiter's strong magnetic field. And Europa's Clipper will of course have cameras that will be taking wide and narrow angle pictures of the surface, providing the first high-resolution global map of Europa. Stereoscopic color images will reveal any changes on the surface due to geologic activity. A separate imager that measures temperatures may help scientists identify warmer regions where water might be closer to the surface. And scientists are looking for a better understanding of the ice shell itself. Estimated to be about 10 to 15 miles thick, which is just crazy, this outer casing may be geologically active, which could result in the fracture patterns that are visible at the surface. Using the radar instrument, the mission will study the ice shell, including searching for water both beneath and within it. And as I said before, the main science goal is to determine if there are places below Europa that could support life. And within that goal, the 3 main science objectives are to determine the thickness of the moon's icy shell and its surface interactions with the ocean below, to investigate its composition, and to characterize its geology. Once the Europa Clipper is fully tested, the team will ship the craft to the Kennedy Space Center in preparation for launch on a SpaceX Falcon Heavy rocket. Now, we've flown by Europa a couple of times before, most famously when Voyager 2 and Galileo had a few flybys in the 70s and 80s. But a lot of that data has been re-examined in the last few years, and evidence has been found that Europa may be venting plumes of water vapor into space. The Hubble Space Telescope has also found intriguing evidence of plumes at Europa. Understanding the composition of these potential plumes could shed light on the makeup of Europa's alien ocean. And obviously our own ocean is teeming with a stupid amount of life of all kinds of sizes and looks and needs. So I think for scientists to want to explore an ocean of that size is a very tantalizing breadcrumb that they just can't ignore. Honestly, it's pretty exciting. I mean, we're still discovering life in our own ocean. So the idea of exploring an ocean that's so many times bigger, who knows? NASA's got a great website dedicated to this mission, which I will put in the description below. NASA also put out a really interesting little video about how scientists and engineers are engaging with Europa in their clean rooms and how they are dealing with the immense radiation that surrounds Europa. I'll post that video with a little introduction over on my Patreon, so if you guys want more info on that, take a wander over there and check it out. Okay, I think that's it for now. It's interesting, right? I feel like a lot of planets we discuss on this channel are more in the vein of rocky tundras or insane dust farms rather than icy oceans. But I think it's an intriguing challenge to discover what, if anything, is under all that ice on Europa. 10 to 15 miles thick of ice. That's a lot of ice. So I'm glad NASA, in all of its insane multitasking, is trying to crack this one, so to speak. Thank you so much for watching. Stuck. Thank you so, I feel like that happens more than I'm aware, that my hair gets stuck on the microphone. Stop. What am I saying? Thank you so much for watching. Please let me know your thoughts in the comments below. And as always, I'll see you in the next video.